example 2 is going to be the same kind of problem as example 1, but we have two new functions. So this time we are given f of x is equal to 3 over x minus 1, and g of x is equal to 2 over x. And so we have two rational functions, okay? So in this situation, not only when you form your composite function, not only is it going to be a little more complex to simplify, but also this is where the domain is going to get tricky, okay? In example 1, we were given two polynomials, so when you compose them, you end up with a polynomial, so the domain is going to be all real numbers, but here it's going to be a different story. Since we're dealing with fractional functions, we know that we can have domain issues both with f and g themselves, so then that means the composite function likely will have domain issues, okay? All right, let's start by finding f of g and its domain in part A, okay? So first thing you're going to do, again, after you recognize from the open circle that this is composition, you're going to write this as f of g of x. Okay, so when you look at this, g is the inside function, it's inside the parentheses. Okay, f is the outside function. Okay, so whatever's inside, okay, that's what we're going to be plugging into the outside function. So we're going to be plugging g into f. Okay, so I'll write that down. We're plugging g into f. Okay, so this is going to actually be kind of a lengthy process. So I'm going to do this on a separate sheet of paper because I don't have a whole lot of room in this box here. Okay, so I'm going to go to the next page. Okay, I'm going to go ahead and write down f of x is equal to 3 over x minus 1, and then g of x is equal to 2 over x. Okay, and we are finding f of g of x. Okay, again, this means we are plugging g into f. Okay, all right, so what are we going to do? Well, we are plugging into f here. F is our outside function. Okay, so do what I do. I write down the outside function. Okay, and now we're going to plug g into this outside function. Okay, so remember, when you're plugging in just plain numbers, okay, if you were doing like f of 4, okay, you would replace x with that number, okay? But now you're plugging in a function, so you're going to replace the x value with an entire function, okay? So again, I've written down my outside function because that's what I'm plugging into. And what are we plugging in? Well, g of x. We're plugging g of x into f of x, okay? So you're going to find your x value, circle it, just the x. Everywhere you see an x, you're going to replace it with g of x. Okay, g of x is 2 over x. Okay, so let's write this out. This is going to be 3 in the numerator. Okay, the denominator is going to be 2 over x minus 1. Okay, now we are going to have to simplify this. Okay, this is something called a complex fraction. It is a fraction within a fraction. Okay, so we need to simplify this so that it's basically not a complex fraction. It's just a normal fraction. You don't have a fraction inside of another fraction. Before I do that, I want to talk about domain, okay? Because we're dealing with fractions now, okay? We know that fractions have bad spots. You cannot plug in an x value so that it would cause division by 0. Okay, so you have to worry about bad spots here. Okay, now here's the big deal. Okay, with composition, I read that statement on page 1 that told you how to find the domain of a composite function, and it just didn't make any sense. Okay, here's what you need to do. Okay, so we just set up the composition. Okay, it's 3 over 2 over x minus 1. Okay, upon initial setup like we just did, you need to stop before you simplify and see what the bad spot is before you simplify. Because once you simplify, the simplification process can potentially cover up the bad spot. Okay, so let me write this up at the top. Okay, you need to check for bad spots. Two different times, okay? First, at initial setup, okay? And then once you simplify, like I said, that simplification process may cover up the bad spot, okay? And then you need to check again once you've simplified, okay? Because then another bad spot may become visible, okay? So after simplification. Okay, and again, this is applying to rational or fractional functions only, okay? So again, we're going to check for bad spots upon initial setup and then again after the simplification process, okay? So here we go. This is initial setup. We just set up our composite function, okay? Let's look at this, okay? We have a fraction within a fraction, okay? I am going to focus here. This is just eyeballing it. Just looking at it, you should be able to see a bad spot, okay? In this little tiny fraction, the 2 over x, x cannot be 0, okay? Because if x is 0, you would have 2 divided by 0, and that's bad. You would divide by 0. So from the initial setup, we can see that 0 is a bad spot, okay? So now we're going to simplify this complex fraction. We're going to turn it into a fraction that's not complex. And then after we simplify, we need to check again for an additional bad spot, okay? All right, so here's what we're going to do, okay? If you're dealing with a fraction within a fraction, you need to work with the numerator by itself and work with the denominator by itself, okay? Let's start with the numerator. It's 3, okay? The easiest thing to do is to treat it as a fraction as well. You can make anything a fraction by putting it over 1. So 3 over 1 is 3, okay? Now, let's look at the bottom, okay? The bottom has 2 over x, and then we're subtracting 1. We need to make 1 a fraction, 1 over 1, okay? So if you notice, the numerator is just one fraction, okay? I'm going to leave it alone. But the bottom, we are subtracting fractions, okay? So you need to recall from your math past, how do you add or subtract fractions? Well, if you're adding or subtracting fractions, you need a common denominator, okay? So I'm going to go write this out to the side. When you add or subtract fractions, you must have a common denominator. Okay. All right, so let's work on the denominator here, okay? All right, so we've got our numerator 3 over 1, okay? In the bottom, I'm going to try to subtract these two fractions, but I need a common denominator, okay? To get the common denominator, you need to take your denominators. The easiest way to come up with this, take your denominators and multiply them together, okay? So the common denominator here is going to be x. 1 times x is x, okay? So in the next step, okay, I'm going to rewrite the denominators here, okay? Each one of these guys is going to be a fraction over x. I want them to have the same denominator. I'm still going to be subtracting in the middle, okay? So we need to go back to each of the fractions, okay? Since the denominator has to be x, we need to see if we need to adjust the numerator, okay? So our first fraction here is 2 over x. It already has the correct denominator, so we don't need to do anything. We're going to leave it, the numerator is 2. However, when we look at the second fraction, the 1 over 1, we need the denominator to be x, okay? It's 1, okay? So we're going to have to change things here, okay? So the easiest way to make this bottom the easiest way to make this bottom x is to multiply by x. If you do it to the bottom, you have to do it to the top, okay? So this fraction is going to become 1 times x, which is x, over 1 times x, which is x. And you can check yourself. The fraction you end up with should be equivalent to what you started with. X divided by x is 1. That's what we had initially, okay? Now both fractions have the same denominator, and we can combine them into one fraction. So in our next step, the numerator is going to remain 3 over 1. The bottom, we are subtracting two fractions over x. So they will combine into one fraction, okay? They will have the same denominator of x, and then you just subtract across the top, 2 minus x. You always go from left to right. My left fraction is 2 and then minus x, okay? So at this point, we have one fraction divided by another fraction. So you've got to remember how to divide fractions. You leave the top one alone, you change division to multiplication, and you flip the bottom fraction. So 2 minus x over x will change to x over 2 minus x. Okay, we're almost there. All right, at this point, we are multiplying fractions. Okay, so to multiply two fractions, you multiply across the top. So 3 times x is 3x. And then you multiply across the bottom, 1 times the quantity 2 minus x. So this whole thing simplifies to be 3x over 2 minus x. Okay, this is your new function. This is f of g of x. Okay, how do I know that I'm done? Well, we don't have a complex fraction anymore. It's just one fraction. We don't have a fraction within a fraction. Okay? All right, so we're done simplifying, so we need to check for additional bad spots. Okay? So when you look at this, okay, to find another bad spot, you can either eyeball it, you can look at this and see what the denominator is going to, what you plug into for x to make the denominator 0. But another bad spot is you're going to get it by taking the bottom and setting it equal to 0. Okay, so if you solve this, you're going to get that your other bad spot is x equals 2. Okay, so you have two bad spots here. Okay, so there's two bad spots. Okay, x equals 2, which we just did, okay, and then the one we had from initial setup. At initial setup, we couldn't plug in x equals 0. Okay, so these are your two bad spots. Okay, now it's worth mentioning, okay, when you look at this final answer, obviously x equals 2 is a bad spot. However, it looks like you can plug in x equals 0. If you plug in x equals 0, you're going to get 3 times 0 over 2 minus 0. That's 0 over 2, which is 0. It looks like you can plug in 0, but you actually can't based on the original f and g. Okay, that's what I was saying. The simplification process potentially covers up the bad spot. That's why you also have to check at initial setup. Okay, so it looks like you can plug in 0 to the final answer, okay, but you can't. Okay, so this is the function. Okay, we're going to go ahead and write down the domain. Okay, again, you can do your little number line thing. Okay, the bad spots are 0 and 2. Okay, so we want to put an open circle to exclude these two guys. Okay, everything else is good. Okay, so the domain here is going to be all real numbers except x equals 0 and x equals 2. And we know in interval notation, if we just read across the number line, this is going to be negative infinity to 0, exclude 0 with parentheses, pick up on the other side of 0, catch everything between 0 and 2, exclude 2 with parentheses, and then pick up on the other side of 2, exclude 2 again with the parentheses, and go off to infinity. Okay, so this is the domain of this composite function. Okay, all right, so this is one example. This is our first example of doing this whole ordeal with fractional functions. Okay, we will do more practice. Okay, but the key is, you've got to remember how to add, subtract, multiply, and divide fractions. Okay, As far as finding the domain here, you've got to remember to check in two places. First, upon initial setup, and secondly, after simplification. Okay, let's take a look at the next example.